Dear students, in this video we are going to learn about the concept of solutions to critical section problem, that is using synchronization hardware method. Under this method, test and set and compare and swap methods are discussed. What is synchronization hardware? Many of the systems provide hardware support for implementing the critical section code. Generally, the solutions uses the idea of locking, that is protecting the critical section entry with the help of locks. But generally, uniprocessor systems will disable the interrupts. That means running the code without preemption. This technique is too inefficient on multiprocessor systems. Therefore, using this disabling of interrupts makes the operating system broadly not scalable. Therefore, modern machines are providing atomic hardware instructions to handle these critical section problems. The atomic means it is executing all the instructions of a function or not executing the instructions within the function. These atomic instructions are non-interruptible. Either they are executed fully or they are not executed at all. The implementation of these atomic hardware instructions using the synchronization hardware techniques such as test and set, compare and swap method. In this video, we are going to discuss about the process synchronization using this synchronization hardware techniques like test and set, compare and swap methods. Generally, any solutions to the critical section problem have the following execution sequence. First, it will acquire the lock for entering into the critical section. Then process performs the execution of statements within the critical section. Then process releases the lock. Then process enter into the remainder section, completes its operations, and then it continues like that. This is the general flow of execution of the statements in any process, having both critical section and remainder section. Test and set instruction is one synchronization hardware method that is used for controlling the two processes for entering into the critical section. Here the process uses a control variable called lock. Initially, this lock variable will be false. That indicates that no process is in the critical section. So when a process wants to enter into the critical section, it will first check the status of this lock, that is the value of the lock. The value of the lock is false. So it passes the address of this lock variable to the function test and set. This function, upon the receipt of this address of the variable, it stores the address. That means it receives the address of the variable into the target variable. That means both lock and target value will be same if any changes are done in this memory address. So target variable is receiving the address of the lock. So it does the changes into this particular address. So what change is done here? The value of the target variable is stored into some temporary variable called as random variable RV. RV is a random variable that receives the value of the target variable. So what is the value passed here? The lock variable value. What is the lock variable value initially? It is 0. So the value of the Boolean variable RV will become 0 now. Now we are changing the contents of the target variable in this memory location. So the content of the target variable becomes true here. That means instead of false, now the value of this memory location will be changed to true. Previously it is false and now it will become true. This function return whatever value is received by this random variable RV, that will be passed as a return value of this particular function. Generally true means 1, false means 0. So here we assume that RV is sending the value of the target variable which is received at the time of calling this function. The value of the target variable initially it is 0, so 0 will be returned to the calling function. Upon the receipt of this value here, 0 is returned to the calling function here. Now this while condition is testing the return value. If the return value is 1, the while loop repeats. If the return value is 0, the while loop terminates. So therefore, 0 indicates that no other process is using that lock variable. So therefore, the while loop terminates. The process will get access to the critical section. While it is performing the action, while it is performing the statements in the critical section, no other process will be entering into the critical section because the value of the lock variable has modified to true in this test and set function. So because the content of the lock variable is changed in its memory address, not in the value. So whatever value was updated in the test and set, that will be reflected in the calling function also. So the lock variable value is 1 here when the process is in the critical section. So when some other process wants to enter into the critical section, that function will again call this test and set by passing the value of the lock as 1 and by passing the address of the lock variable with whose value is 1 now. So when it is passed to this test and set instruction, then the target variable value will be 1. The address of the lock variable is taken by the target and the random variable RV will be taking the value of the target variable, that is 1, and target variable value will become true. That means 1 remains 1. Then the test and set function, whatever value it is received at the beginning with the target variable, that value only returned to the calling function, that is the RV value is 1 will be returned to the calling function. So when 1 is returned here, the while loop test condition is true. That means while loop will not terminate, it will again repeat. That means the process which is trying to get access to the critical section will not go out of this while loop because the while loop condition is true here. So therefore, the process will keep on checking this while condition to terminate. As long as the other process which is in the critical section does not make the change in the lock variable, this process will be keep on running, waiting for the while loop to terminate. So when the previous process P1, when it terminates, when it completes the execution in the critical section, then it will change the lock variable value to false. It changes the value of the lock variable to false and then it come out of the critical section and enter into the remainder section. Then the process P2, which is hold in this while loop, which is waiting for the termination of this while loop, the value of the lock variable now has become 0. When it is 0, when it is passed to this test and set function, this function returns 0 only, but the lock variable value will be changed to 1. So it returns 0 and lock variable value will be turned to 1. So that means the while loop will be terminated for this particular process and the lock variable will become true and process will enter into its critical section and complete its execution. This lock variable true will be not permitting the other process's entry into the critical section. In that way, this execution continues for all the processes who wants to enter into the critical section one after the another by making use of this test and set function call. This test and set function call is possessing all the properties of the critical section solution. One is mutual exclusion because only one process is permitted to enter into the critical section. Therefore, mutual exclusion condition is hold good here. Progress is also hold good here because when one process wants to enter into the critical section and any other process, no other process is in the critical section, this process is permitted to enter into the critical section immediately. Bounded waiting also, every process upon its termination from the critical section, it is releasing the lock so that other processes which are waiting for that lock is entering into the critical section. So therefore there is no indefinite bounding. So therefore every process will guaranteely get access to the critical section. Compare and swap instruction is also one more method of controlling the critical section problem. In this compare and swap function, a lock variable and key variable will be used by the process. A process which wants to enter into the critical section, initially it will hold the true value, key variable value will be true and the lock will be false because no process is in the critical section. So key and lock variable values will be changed when we call this swap function. The key and lock variable values will be swapped in the swap function. So if key is true, lock is false, then key becomes false and the value of the lock will be true. So in that way, the swap function will interchange the value of these two variables by passing their addresses. So now let us see the execution of this while loop for these initial values of key and lock. The initial value of key is true, initial value of the lock is false. So since key is true, the process wants to enter into the critical section, it will call the function swap function for this lock and key by passing the address of the lock and key. The swap function is taking the address of lock and key into A and B variables, and these values are interchanged with the help of another temporary variable temp. So when lock is false and key is true, after interchange they become lock true and key false. So when control returns to this while condition, the value of the key, previously it was true, now it became false. This false condition, this false value of key terminates this while loop because this statement will become false now. So that means no other process is in the critical section. So this process is acquiring the permission to enter into the critical section. So what is the value of key now? Key value is false, lock is true. Now lock is true indicates that some other process is in the critical section, lock is true. So after completing the process execution in the critical section, process comes out and it will change the value of the lock into false. The process will commence its execution in the remainder section of the. In this way, this process will repeat as many number of times as a process wants to continue its execution in the system. Now we'll take the another process P2 which is waiting for entry into the critical section. Now it is checking the value of the lock variable when the first process P1 is in the critical section. When P1 is in the critical section, the lock variable value is true. So now the P2 is checking the entry condition while loop. The key value is false and lock value is true. So key value is false, lock value is true. These two values are passed to the swap function. What the swap function will do? It will interchange these two values. That means lock becomes false, key becomes true. So while key is equal to true, what happens? This condition is true. The while loop repeats. This while loop will keep on continuing until the key value is changed. So likewise, the process P2 do not get permission to enter into the critical section because the while loop will not terminate for that process. So as soon as the process P1 come out of the critical section, it is changing the value of the lock into false. So what happens when lock value is false and key value is also false? When they are passed on to the critical section, the swap function, then this lock and key values will be interchanged and then the while loop will terminate for the process 2. In that way, process synchronization between two processes will continuing the processing critical section problem. Now let us see if more than two processes are there, how this test and set function is synchronizing the multiple processor for entering into the critical section. Here an additional variable is used, that is waiting is an additional variable that will check whether the process wants to enter into the critical section or not. The waiting variable value of any particular process is true. That indicates that the process wants to enter into the critical section. So initially key is equal to true and waiting status of the process I is also true. So I is true. Key value is also true. Now the while condition, while loop is testing the condition. What is the waiting status of I? The process I wants to enter into the critical section, so it is true. What is the key value? That is also true. What is the initial lock value? That is false, because no process is in the critical section. Now we are passing the value of this lock to the test and set function. Whatever value we send, the same value we will get back, but the lock variable value will be changed to true inside the test and set function. So we are sending the value false, we will receive the key value as false here. So now the key value is changed to false and lock variable was changed to true inside the test and set function. This while loop will check the value of the waiting variable value for I and the key value for this particular process. So the value of the key is false. The waiting status of that particular process is true. So true and false, this becomes false. The while loop terminates. That means the process is acquiring the permission to enter into the critical section because no other process is in the critical section. So process waiting status will become false. Process enter into the critical section. When it comes out, the process I decide who is the next process to enter into the critical section by using this statement j is equal to I plus 1 mod n. So this will generate the next process to enter into the critical section. If I is equal to 1, j becomes 2. When I is equal to 3, j becomes 4. When I is equal to n, j becomes 1. That means it will generate the numbers in the rotation basis. So likewise, one after the another process will get chance to enter into the critical section by using this statement. Now j is generated. Now the j value is checked whether j is really interested to enter into the critical section. If the waiting status of j is true, means j wants to enter into the critical section. If the waiting status of j is false, means it don't want to enter into the critical section. So in that case, if j is not I, that means if the turn is not for I and j don't want to enter into the critical section, then next j value is decided. So if j is 2 but j don't want to enter into the critical section, then j becomes 3. And j3 is also not willing to enter into the critical section, then j will become 4. Likewise, the next process j is decided in this while loop, and one process which wants to enter into the critical section, there the waiting status of that particular process will be true and the negation of true will be false here. The while loop will terminate and control will come here. Making this lock variable false makes the process I to enter into the critical section because the process I itself is getting the next turn to enter into the critical section because no other j process is ready to enter into the critical section. So therefore the turn for I has come again. So the lock value for the process I becomes false now. And so for example, if j is not equal to I, then the waiting status of the j process which is willing to enter into the critical section becomes false, and the process which is blocked waiting in its process in this while loop for acquiring the entry into the critical section, this waiting status becomes false, terminates the while loop for the J process. And that J process will enter into the critical section because the waiting status is terminated and the lock variable value is equal to false. So in that way, the J process will enter into the critical section, and this process I will be entering into the remainder section. So likewise, when one process is in the critical section, the another process will be in the remainder section. So likewise, this method will generate the entry for every process in sequential order on rotational basis to access the critical section resources. Thank you for watching this video.